Today we're going to learn how to create an RLC circuit in LTspice. LTspice is a great circuit building program for beginners and experts to use. To start, we'll need a computer able to run LTspice and LTspice downloaded. Download LTspice from the link provided, and let's get started. Create a new schematic file by pressing Ctrl-N or, alternatively, File, New Schematic. Click on the component icon on the toolbar, or press F2. This will bring up a Select Component symbol menu. Scroll to the right to find the voltage item. Click on the item, then click OK. Place your voltage supply symbol anywhere on the canvas, then press Escape. Right-click the voltage supply symbol. This will open the voltage source pop-up box. Click on the Advanced button. The window will now expand into the independent voltage source panel with full DC and AC options. Under Functions, click the listing for sign. We'll be entering the following values for the AC voltage source: DC offset of 0, amplitude of 100, and frequency of 50. Then click OK to return to the drafting canvas. Click on the resistor icon on the toolbar or press R. You can press Ctrl-R to rotate the component. Place your resistor accordingly on the canvas by clicking once. Press Escape to return to the selector cursor. Then right-click the R text on the bottom part of the resistor symbol. Enter your resistance value in the box. For this circuit, we will be using 12 ohms. Then click OK. We're now going to select an inductor by clicking on the inductor icon on the toolbar or press L. We can rotate this again by pressing Ctrl-R. Place your inductor accordingly on the canvas by clicking once. Then press Escape to return to the selection cursor again. Right-click the L text on the bottom of the inductor symbol. Enter your inductance value in the box. We will be using 0.15. Click OK. We'll be selecting a capacitor by clicking on the capacitor icon on the toolbar or pressing C. Place your capacitor accordingly on the canvas by clicking once. No need to rotate. Right-click the C text on the bottom of the capacitor symbol. Enter your capacitance value in the box. For the circuit, we will be using 100U. Then click OK. So what happens if we mess up? We can use the Move tool to select a component and move it wherever we wish. This can be useful if you want to tidy up your circuit after you've already made your components. Another feature is the Delete tool. It is located on the toolbar and it looks like a pair of scissors. You can use it in the same way as the Move tool to select a component, but as soon as you select it, it'll disappear. This is also useful if you've made too many components. Okay, now we are ready to wire the circuit. Click on the Draw Wire icon on the toolbar or press F3. Connect the components by clicking one end of the small blue end cap squares to the other. First, wire the voltage source to the left end of the resistor. The right end of the resistor will be connected to the left end of the inductor. The right end of the inductor will be connected to the left end of the capacitor. And finally, the final end of the capacitor will be connected back to the voltage source. Press the Escape key once the circuit is completed. If you messed up a little bit on this step, the Delete tool is useful here as well. Click on any unwanted wires with the Delete tool cursor active to delete them from the canvas. Finally, we're going to add ground to the circuit. Click on the ground icon on the toolbar or press G. Place your ground anywhere on the circuit's wiring where you want ground to be. I would recommend ground at the opposite end of the voltage source, under the capacitor. And there you have it, your finalized RLC circuit. I hope you learned a lot about how to use LTspice and how to build a circuit. In this optional part of the tutorial, I'll show you how to run a quick simulation. Navigate to Simulation and then Run. A simulation command box will appear. In the Transient tab, enter a stop time of 0.1. Also, ensure that the Start External DC Supply Voltages at 0 checkbox is marked. Press OK. The waveform for Node 1 will now appear in a simulation window. Right-click anywhere in the simulation graph window, then click Add Traces. Select any of the plots to view from the available list, then click OK. We're going to use V1, V2, and V3. In theory, changing the voltage source of the component values will affect the circuit. We're going to try changing the value for R1, or the resistor, to 1200 instead. We're going to run the simulation again and see how this goes. We see that the graph has changed drastically. V1 now shows a pretty high amplitude, while now we have a low-pass filter where the inductor and the capacitor are extremely small in the voltage values. Thank you for watching.